Hello, this is Jennifer Martinez. In this video, we're going to introduce arc length of a circle. What is the arc length? Well, the arc length, usually denoted by S. So if you look here on the right side, there is a circle with a little arc length in orange labeled S. And that arc length intercepted on a circle of radius R. So let me go ahead and make this radius R. By a central angle of measure. So from here to here, this arc length is intercepted by that angle theta. And it's given by the product S equals R times theta. Again, R is the radius, theta is the angle intercepted by that arc length. And theta, by the way, is in radians, where theta is in radians. Where does this formula come from? Well, it's a geometric fact, which states that the length of the arcs are proportional to the measure of their central angles. So if you look at 1 radian here, let me do this in a different color. If you remember 1 radian, this distance R, it's about maybe right there, is 1 radian. Again, 1 radian from our last section meant the distance R along that arc. So that distance is 1 radian. It's R away. And if we look at the proportion S over R, the length of this arc over the length of this arc, that is proportional to the central angles. So this central angle is theta, and then this central angle is 1, both in radians. If you multiply both sides by R, you indeed have the formula. When you use this formula, when the formula S equals R theta is applied, make sure the value of theta is in radians. It must be expressed in radians, not degrees. It does not work in degrees. It's because of the fact we use that 1 radian there. So let's look at an example of this. Find the arc length using S equals R theta. So a circle has radius 18.20 centimeters. Find the length of the arc intercepted by a central angle having each of the following measures. So the first one is 3 pi over 8 radians. This is already in radians, so that is good. Just to draw this, we know that I'm going to divide this into eighths. Here's 1 pi, so 3/8 pi. Here's something divided into 8. Right? 1, 2, 3, 4, 5, 6, 7, 8. So this would be pi over 8, 2 pi over 8, which is pi over 4. That makes sense. 3 pi over 8. So pi over 8 is an angle in the first quadrant. And the circle had radius 18.20. So I drew a little arc here, right, because the whole circle, the radius is 18.20 centimeters. They want to find this arc length, that S. So we're going to just use our formula. And the R is going to be 18.20 centimeters. And we're going to multiply this by our theta, our in radians, 3 pi over 8. Which I could just do on my calculator. 18.20, you don't really need that 0, times 3 pi can be found second, and this this caret here, right under the clear, and then I'm going to divide it by 8, and we should get the arc length about 21.4, and that is in centimeters since the radius was in centimeters. And that would be the answer. If you had a degree, be careful. Let's go ahead and first draw this. we have here, let's just do our circle. 144 degrees would be, this is 90, this is 180, so 144 degrees would be somewhere there. So this would be our arc length in orange there. And our angle is 144 degrees. Our radius is still 18.20 centimeters for both part A and part B. So I'm going to take S is equal to R times theta. But the problem is theta, if you remember, must be expressed in radians. So what I'm going to do is change this into degrees. And if you remember how to change something into degrees, is you're going to take it and you're going to multiply it by pi over 180. So I'm going to take the 144 times pi over 180. We can reduce that first, but we're just going to get a decimal. We can use our calculator. Again, theta is 144 degrees, which is the same thing as 144. We want to get out of degrees and into radians. So we know pi, there's 180 degrees in pi radians, and so that's why it's 144 pi over 180. So let's do this on our calculator. We still have 18.20, and now we're going to times it by 144 pi, and again you could reduce that if you'd rather, but I'm just going to leave it. Divide by 180, about 45.7. And again, it's in centimeters since the radius was in centimeters. So let's look at an application of this. This example is going to be finding the length using S equals R times theta. So we have a rope that's being pulled around this drum, and the radius is 0.8725 feet. Here's the figure on the right. How much rope will be wound around the drum if the drum is rotated through 39 degrees? And it shows a picture there. So you can see how much rope is being pulled would be the same distance as that arc length. So all we got to do is find the arc length here. So again, S equals R times theta. So this time R is 0.8725 feet. Theta is 39.72 degrees, but you cannot be in degrees. If you remember, it needs to be in radians. So again, I want to get out of degrees. So I want to multiply by pi over 180. That is going to be what this is in radians. Again, let's just do that over here. So the conversion is, I think of degrees and I'm going to go to radians. And I know there's 180 degrees is pi radians. So that's where I get the 39.72 times pi divided by 180. So if I just take 0.8725 and multiply that by, you can hit the multiplication sign, or you could just do the parentheses like I did, 39.72 seconds caret to get the pi divided by 180. The answer is about 0.6, or maybe we're going to go out 4 places since this went out 4 places. 0.6049, because that's a 5 after the 8 there. And this time we're going to be in feet, since the radius was in feet. And that is the answer. The most common error in this section is not changing the angle in degrees to radians. Theta always needs to be in radians. So do not forget that. Theta in degrees does not make sense with our formula. So theta has to be in radians. So if it's in radians, you leave it, like I did example 1a, but example 1b, if it's in degrees, I need to change it. Hope that helps.